Bismillah, Alhamdulillah, wassalatu wassalamu ala Rasulillah. This is section 6.4, and we will talk in this video about the present value of an annuity due. We have seen that in 6.3 that the difference between annuity due and ordinary annuity is the time in which we receive the payment or put the deposit. So here in section 6.4, we have payments are because the lump sum is present now, so we call it present value, and annuity due because the payment is made at the beginning of each period of for n periods, while if the payments are made in at the end of each period, it will be called an ordinary annuity. So that's the only difference between annuity due and ordinary annuity. And notice that because of this difference, we just multiply the formula of ordinary annuity by 1 plus I. So that's the difference between annuity due and ordinary annuity. We multiply the formula of ordinary annuity by 1 plus I, whether we are talking about the present value or the future value of an annuity. Everything else is the same, are the payments. I is the interest rate per period, and N is the number of periods. So let us go to the examples. A lottery prize worth 1,200,000 is awarded in payments of 10,000 at the beginning of each month. Beginning of each month, so this is an annuity due for 10 years. So what would be in the number of periods? 10 years and monthly, so 12 times a year. So the number of periods will be 120 periods. And the interest rate per period, 7.8% compounded monthly, so 0.078 divided by 12. And if you use the calculator, you will find that the answer is 0.0065. The question, what is the real value of the prize? So the prize worth 1,200,000, but this is not the real value that the winner will receive because there are taxes, expenses, and so on. So what is the real value of the prize? The real value would be the present value of the annuity due, okay? And it is R. Yeah, if you want, I can write AN due, but I will always write it AN for simplicity. Okay, so AN is R, which is 10,000 times 1 minus 1 plus I, and 1 plus I is 1 plus this number, and it is 1.0065 to the power of negative n over 0.0065. This is I. Now times 1 plus I because it is annuity due. 1 plus I is 1.0065, this number. Use the calculator, multiply all of these numbers, and you will find that the answer is 836,843.55 dollars. So this is the real value of the price. Another example, suppose that a court settlement results in this amount, okay, 750,000 award. So this is a settlement. It is now present. So you can say that this is AN. If this is invested at 9% compounded semi-annually, so the interest rate per period semi-annually twice a year is 0.045. How much will it provide at the beginning of each year? So he is asking about R, the payments, beginning of each year. So this is annuity due of each half year, sorry, for a period of 7 years. So 7 times 2, twice a year. The number of periods is 14. So we have AN here, and R is missing. 1 minus 1 plus I, so 0.045 to the power negative n over 0.045 times 1.045. This is 1 plus n, okay? And we can find R by dividing this amount by this amount. So divide this by this, or calculate this first and then divide 750 by this number. And using the calculator, the answer is $70,250.97. So these are the payments. What lump sum will be needed to generate payments of $5,000 at the beginning of each quarter for a period of 5 years? 4 times 5. If money is worth compounded quarterly. So interest rate per period is 0.07 over 4 using the calculator. This is 0.0175. So what lump sum will be needed? So this is the present value of the annuity due that we need now, okay, to generate this these payments. So AN would be 5,000 R times 1 minus 1.0175 to the power negative 20 over 0.0175 times 1.0175. And using the calculator, just put this in the calculator. The answer is 85,230.28 dollars. So this is the lump sum or the present value of the annuity needed to generate 5,000 at the beginning of each quarter for 5 years. Is there any difference between the present value in Part A and Part B? Well, in Part A, an annuity due, okay, so the present value of this annuity due would be 1,000, that's R, times 1 minus beginning of each year for 10 years. Okay, I is not given. So beginning of each year, so let us say that 10% compounded annually, okay? We just put it from ourselves. Okay, you can use monthly, sorry, you can change this 10%. You can use 9%, 8%, whatever, any percent. In case of, because I need to calculate, so I will use 10%, the easiest one in my opinion. So 1 plus I, so 1.1 to the power negative 10, because 10 years, over 0.1, which is I, times 1.1, because it is an ordinary annuity. If you put this in the calculator, you will get the answer $6,759.02. What about part B? Taking $1,000 now, okay, and establishing an ordinary annuity, okay, that pays 1,000 at the end of each year for 9 years. Okay, I'll use 10% annually also. So I'll take 1,000 now. So this is this amount, I'll take it. And I'll take what? AN, the present value, okay, of this annuity that pays at the end of each year for 9 years. So the present value in this case would be 1,000, which is this one R, times 1 minus 1.1, but to the power negative 9 because 9 years over 0.1 n, and without multiplying by 1.1 because it is an ordinary annuity. And if you calculate this, if you put this in the calculator, you will reach the answer, this answer, the same answer. So no, there is no difference. And this tell you that this is actually how we obtained the formula for annuity due, because we can look to annuity due as an ordinary annuity for less one period, that's less one period, and one payment will be taken immediately. So instead of annuity due that pays 10,000 at the beginning, 10,000 beginning of each year, I will take the first payment now, and then I will deal with the other 9 periods as ordinary annuity. And you can from here, from part B, you can check that these two actually formulas are the same. So if you take 1000 as a common factor for here in part B, you'll have 1 plus 1 minus 1.1 to the power negative 9 over 0.1. And if you add these two fractions, you will have 0.1. 1 times 0.1 is 0.1 plus 1, okay? And 1 plus 0.1 is 1.1 minus 1.1 to the power negative 9 over 0.1. And actually this one is exactly this one, because if you take 1.1 as a common factor, okay? So let me take it as a common factor and write it here. So I'll have 1 minus 1.1 to the power negative 10, because negative 9 minus 1, because we are dividing when we take a common factor, okay? So exactly this one, that's the same formula in AN. So that's what we do actually. That's why 1 plus I is here, okay? That's why you understand now why 1 plus I is here, because of this exercise uh, that enables you to understand the difference between ordinary annuity and annuity due. Find the present value of an annuity due, so AN due, that pays 3,000, this is R, at the beginning of each quarter for the next 7 years. So N is 28, I is 0.058 over 4 each quarter, and this would be, if you use the calculator, 0.0145. So AN would be R, which is 3,000 times 1 minus 1 plus I to the power negative n over I times 1.0145, which is 1 plus I. And if you use the calculator, the answer would be $69,632.02. What amount must be set aside now to generate payments? So these are the payments, and the amount we need to set aside now is AN at the beginning of each year for the next 12 years. So N is 12 and I is 0.0592 because compounded annually. So AN would be 50,000. That's R times 1 minus 1 plus I to the power negative n, which is negative 12 over I times 1 plus I. And you can use the calculator, multiply these numbers, and you will find that the answer is 445,962.23 dollars. Recent sales of some real estate and record profits make it possible for a manufacturer to set aside 800,000 in a fund to be used for modernization and remodeling. So this is the amount we'll set aside. This is the present value. How much can be withdrawn from this fund? That are the withdrawals or the payments at the beginning of each half year. So annuity due for the next 3 years, semi-annually twice a year. So N is 6 and I is 0.077 over 2 twice a year. So I would be 0.0385. So AN is given, R is unknown, 1 minus 1 plus I to the power negative N over I times 1 plus I, and R would be the division of this 800,000 over all of this amount. And the answer would be 140,235.06. That's the answer, and I hope you understand now the present value of annuity due. Thank you very much. Have a nice time.